Okay, I'm going to do the back side of the worksheet 11, 13, 14 on ion configurations. What is characteristic about transition metals? Um, they tend to be colorful and multiple charges. Okay, one of the reasons they're colorful, the d electrons, we always portray the d electrons as they're on the same level, but the last two are kind of not degenerate. They're higher in energy, slightly. So when we fill d electrons, they still will fill following its Hund's rule, and then we'll go opposite. Okay, what makes them colorful is that these electrons can jump to a higher level and back down easily. It's a low energy jump, but that energy jump gives off light in the form of color. Okay, so as long as your D's have an open orbital, they tend to be colorful. If all the orbitals are full, they can no longer perform those jump and they won't have color. So the word chromium, chromatic, means many colored. Manganese has many oxidation states because they can also shift electrons around. Some of these things can have up to like 8 oxidation states. Vanadium is Latin for also meaning very colorful. But when it comes to zinc, cadmium, and mercury, they all have a full D10 and they're all colorless in solution. Now for silver, it takes the one electron and fills up its D10. So silver is also colorless in solution, and so is copper 1. But if you lose that second electron, you get a D9, so copper 2 is blue. It can do transitions. Gold, if it's got a +1 charge, it's colorless. But if you lose more electrons, then it picks up a color because the D can jump up and down. All right, here we go. What periodic trend characterizes metals? Metals have low, this doesn't line up well. Ionization didn't print well. Energy. Nonmetals, high electron affinity. Or you could say high electronegativity. For metals, we don't say anything about electronegativity because it's not about gaining electrons, it's about losing them from metals. Okay, we go back to our Leo the Lion goes grr. Metals tend to lose electrons. Non-metals tend to gain. Okay, and remember, Leo stands for losing electrons as oxidations. This is the next one. GER means gaining electrons means reduction. My dog's going to be in trouble. The process is called oxidation. The process is called reduction for Leo and Gur. What's the most reactive metal? That would be cesium. I'm okay if you said francium. I don't know what I'm saying there. Dog, come here. What are 4 characteristics of metals? They have a high luster. They're conductive to electricity because they hold electrons loosely. They're conductive to heat. And malleable. Malleable because metals are large. The attractive forces aren't so high, so they can actually shift because they don't have a high attractive force to each other. Okay, that's metallic bonding, which I really didn't get to kick on too much. They're also ductile. That just means you can turn them into wires. Non-metals are everything metals aren't. Instead of having a high luster, they're dull. Okay? Instead of being conductive, they're non-conductive. To heat and electricity. And instead of being malleable and ductile, nonmetals tend to be brittle. Brittle because they have a high attractive force to them, so they're held in a crystalline structure, and if you break that structure, it's just going to break on you. Things with metallic bonding, it comes down to the outer electrons. If I have a metal like gold, you normally would think of, okay, what would really hold the atoms of gold together? How come it's not like a liquid? Well, if the force was low enough, it would be a liquid, and that's the case with mercury. Okay? But the s electrons, they all have s1 electrons. Now, we normally think of the electrons being held by each gold atom, but the s electrons actually are mobile. And what holds them in place isn't a single nucleus. It's the effect of all the nucleuses and all the gold in the middle. So metallic bonding is different. I always describe it of having like a bag of sand. So the electrons around the outside can freely conduct. They conduct heat and electricity. But these electrons can be easily excited, so it has that high luster. And the other thing is, I would compare this to like the Earth. The Earth has an atmosphere, and if it was just gravity holding on to one single molecule, gravity is such a low force that the molecule would just fall off into space. It wouldn't keep it there. What keeps the atmosphere in place is the fact that all the molecules in the air have those intermolecular forces, van der Waals forces. So they all have an attraction to each other. So as a whole, all the mass of the Earth holds all the mass of our atmosphere in. And that's kind of similar to what I'd see like in metallic bonding, that all the protons in the gold would hold all these. And that's the metallic bonding. It's sometimes referred to as a sea of electrons. And that's unique to metals. And I would say, I can say that it's like sand inside a Ziploc bag. If you hit it with a hammer, it bends, it takes the hit, it's malleable. You can bend it, and you can pull it, so, it's and it's soft. So it has a characteristic softness. All right, let's just go down this real quick. What's the most common charge of alkali metals? +1. Alkali earth, +2. Pnictides is -3. Pnictides are group 15. Okay. Chalcogen family's oxygen, -2. Halogens are -1. And configuration and charge, noble gases are usually 0. Okay. What's the configuration? All alkalis are S1. Alkaline earth, S2. Pnictides, S2P3. That's 5 valence electrons. And valence electrons, 1, 2, 3, 4, 5, 6, 7, 8. So the oxygen family. Now I'm not drawing them with their charges. This is the one that gets lost to be the +1. This is the 2 that gets lost to become the +3. You're gaining 3 to become P6. So these are gain 2. They're S2, P4 would be the oxygen family. Halogens are LS2, P5. Now when they gain these electrons, they all would be like noble gases, S2, P6. And that's what we mean by isoelectric. Isoelectric means the same number of valence electrons. What type of configurations do most ions tend to take? Noble gases. That's it. I'm going to do a video on the review sheet, and then we're done.